Hi everyone! Today I'm going to discuss to you the introduction to XRD analysis. So it is an overview of XRD analysis, including its principles, instruments, and techniques used, application, advantages, limitation, and example of XRD spectra. For UNPS, we have TiO2 nanoparticles and UNPS TiO2 hybrid nanoparticles. This is prepared by me, J.C. Dulog. So, so let us start with the question, what is XRD analysis? So let's look deep inside this matter. So first, the XRD stands for X-ray diffraction. It is a non-destructive analytical technique used to study the crystalline structure of materials at a molecular level. Second is unleashing the power of X-rays. So XRD analysis involves bombarding a sample with X-ray and measuring the resulting diffraction pattern to discern the arrangement of atoms within the material. And lastly, revealing the hidden secrets of these materials. So by analyzing diffraction patterns, we can determine important characteristics such as crystal structure, phase composition, and even sample purity. So these are the principles of XRD analysis that we can use to analyze the samples. First is we have the wave-particle duality at play. So XRD analysis relies on the wave-particle duality of X-rays as they behave both as electromagnetic radiation and as stream particles called photons. Next is this Bragg equation, unlocking the secrets. So by applying the Bragg equation, which relates the wavelength of the X-ray beam to the spacing of crystal planes, we can determine the crystal structure and lattice parameters using this equation. The third one is from intensity to peaks. So after obtaining the diffraction pattern, we analyze the intensity and position of the peaks to identify crystal structures, the phase transitions, and crystal defects. So what are the XRD instruments and techniques used in this study? The XRD instruments are laboratory-based XRD machines. We have also portable XRD devices, which you can carry anywhere. So we have XRD techniques. First is we have powder XRD. The second is the single crystal XRD and the thin film XRD. So these techniques uses different material. Techniques is used depending on the materials being analyzed. For example, for gold, we use thin film. So for the TiO2, we can use this powder XRD and or this single crystal XRD. So how to interpret the data of the XRD analysis? First is we have identify the peaks. So distinguishing the positions and intensities of the peaks in the diffraction patterns allow us to identify the crystal structure and phase composition of the sample. So here, by looking at the peaks, we can distinguish in what position where the material is or what material did you use in the experiment, in the analysis rather. Next is the peak broadening. So the broadening of peaks can provide insights into the size, the strain, and the effects present in the crystal structure. And last is the Rietveld refinement. It is the advanced data analysis techniques such as it will enable precise determination of the crystal structures, unit cell parameters, and atomic coordinates. So in this rate build refinement, you can see the crystal structures and coordinates uh, uh, of what material is present in the sample. So what are the applications of XRD analysis? So we have the materials and characterization. It identifies crystal structure, phase composition, crystallinity of the materials, such as minerals, metals, and pharmaceutical compounds. So these pharmaceutical compounds, which we can see in our medicine. For example, we have the penicillin and other sources of pharmaceutical compounds. Next is the quality control. So verifying the purity and homogeneity on consistency of materials in manufacturing processes such as semiconductor and pharmaceutical industries. Next is the environmental analysis. So it investigates the composition and structure of pollutants, air particles, particulates, and soil sample to assess environmental impact. Last is archaeology and cultural heritage. Studying the crystalline materials in artifacts, ceramics, and historical structures is used to understand the origin, the age, and preservation of the material being analyzed. So what is the edge of this XRD analysis among the other analysis? So these are the advantages of the XRD analysis. First is we have the XRD analysis is non-destructive. So it does not require the sample alteration, allowing for further characterization or reanalysis. Second is when we say non-destructive, the materials being analyzed can be used to analyze again, or you can reanalyze it, or you can rerun it in the XRD machine. So second is the high sensitivity. The technique is capable for detecting small changes in the structure, even at low concentrations. For example, you have the hybrid nanoparticles. You can detect the small changes in the crystal structure by determining its the uh, the uh, the peaks be in the XRD spectra, which I have shown a while ago. So using that, you can detect such materials be present in your sample. So the third one is the quantitative analysis. So integrated software enables accurate quantitative determination of phase, percentage, and crystallographic data. So using that, by getting the raw data, you can extract in the XRD analysis. You can create quantitative information, then analyze it so that you can discuss it in what kind of materials you are studying with. So if we have advantages, we also have limitations on XRD analysis. First is the crystallinity requirement. So XRD analysis only applicable to crystalline materials and cannot analyze amorphous substances. So when we say uh, crystalline materials, we can have the semiconductor, the metal oxides. When we say metal oxides, it should be incorporated with metal. So, for example, in this analysis, the hybrid nanoparticles, you can create this into the powder form, and then you can study the crystalline structures of that sample you have. The second is the sample preparation. So proper sample preparation such as grinding or crushing if you make a powder, it is necessary to obtain a representative sample for analysis. So the finer the sample, the better. So we have also the cost and expertise. So this requires instrumentation and data interpretation may be expensive and requires specialized training and expertise. So these are the limitations. So it is very costly and needs an expertise to analyze the data you have obtained in your sample. So we have the XRD analysis on ENTS, TiO2 nanoparticles, and these EUNTS TiO2 hybrid nanoparticles. So for EUNTS, it investigates the crystallographic properties of gold nanoparticles and understand their size, shape, and stability for applications in nanotechnology and catalysis. So for TiO2 analysis, it also studied the structure and phase composition of titanium dioxide nanoparticles in a versatile material widely used in solar cells, sensors, and most importantly, photocatalysis. That's the prowess ability of these TiO2 nanoparticles. So for the hybrid nanoparticles of AUNTS and TiO2, it also characterized the structure and properties of hybrid nanoparticles, formed by combining gold and titanium dioxide, exploring their enhanced functionalities and potential applications. So these are the examples of XRD spectra of the three chosen samples, especially the EONPS, the TiO2 nanoparticles, and the hybrid nanoparticles of both materials. So for the ENPS, we have the X-ray diffraction that reveals the crystalline nature of gold nanoparticles, showcasing distinct peaks corresponding to the well-defined Bragg reflection. So the intensity is higher at a higher reflection at 1111. We have also 200, 220, and 311 of a face-centered cubic lattice. So this notably that these from this 31 peak at 38.1 degrees signifies a pronounced growth reference to the crystallographic direction of the gold nanoparticles. So for TiO2 nanoparticles, the spectra, the diffraction spectra peaks the characteristics of the diffraction peaks in the XRD spectrum is in the anatase phase. So the diffraction peaks appeared 2 theta at 25.23 degrees. We also have a peak in the 37.71 degrees, 47.72 up to 62.54. So they were all index of the corresponding tetragonal crystal plane of 101, 004, 200, 105, 221, 211, and 204 respectively. So for the hybrid nanoparticles, we have the XRD spectra illustrating the unique crystallographic information obtained from hybrid nanoparticles. So three reflexes of gold nanoparticles are observed, which located at 38.1, 1111, 44.3, 200, and 64.5, 220. So this is a unique reflexes which we can see in the gold particles. So the only crystalline TiO2 phase detected in the sample is anatase. So we can compare that the samples of EU the samples that the XRD spectra of EU and PS and TiO2 nanoparticles is present on the nanohybrid particles of both material. So there is no indication for the presence of rutile since metastable phase is evident. So we can see if we can combine these two nanoparticles. So HRD analysis is the combination of these two spectra from ENTS and TiO2. So which we can clearly see in the figure of this the third figure of these hybrid nanoparticles. That's all for today. I hope you learned. Thanks for watching.